Now then, so we've looked at the gases, hydrogen and oxygen, that make up water. We're now going to look at water itself. And water, well, it's a liquid, but what exactly is a liquid? Well, this is actually quite tricky. Before we look at a liquid, perhaps we should look at the solid. Solid is in many ways easier to understand. So here I have some solid water, also known as ice. Okay? Now, what does this look like? If we could look very, very closely and see all the molecules in this, we would see that they were all arranged in a regular pattern, okay, rather like this sort of thing. Okay? So we still have our water molecules intact with each oxygen connected to 2 hydrogens, so here they are, but now they're all linked together in a regular pattern. But as the thing warms up, so we give it some energy, it warms up, the molecules start moving about, and we get a liquid. And they're still sort of connected together in lumps like this, okay, but they tend to go all over the place, like that, okay, but they're sticking together and moving around. Well, this is sort of what a liquid is like. Right, now, we have an animation here to show what liquid water is like. This was actually made in the department here using a supercomputer to calculate what would 32 molecules of water, the same number that we have hanging from the ceiling here in the mobile, what they would look like at about 30 degrees C. Now notice they're all jiggling around. Also notice that during this, as they're moving around, we see some of the yellow dotted bonds forming and disappearing, reforming, disappearing. These are called hydrogen bonds, and these are weaker interactions than the interactions between the hydrogen atoms and the oxygen atoms themselves. But these hydrogen bonds form momentarily and then disappear, but it's these that actually hold the water molecules together and keep water as a liquid. So rather than being a gas, the water is a liquid because the 2 water molecules or more are held together by these weaker interactions called hydrogen bonds. So we can still separate them, and these hydrogen bonds form and reform and stick together like so. Okay? And it's these that keep the molecules together as liquid water. Now, why do we get these hydrogen bonding interactions? What are they? These are actually due to the charge in the water molecule being arranged in, well, not in a symmetrical fashion. More of the negative charge is associated with the oxygen, and more of the positive charge with the hydrogens here. And so this means, well, they can connect together, but they always connect together with one hydrogen connecting to the oxygen, hydrogen to oxygen from the separate water molecules. That's how they stick together.